Hello everyone, welcome back to Coursera. Today we are again back with another problem solving question. So today's question is more based on the algorithm which we have understood, and that is binary search. So although this specific question we can also solve it without using that specific algorithm, but the thing is, or the ideology is, we have to understand the algorithms. The previous videos which I have posted on Coursera that are also sorting algorithms, you might skip those algorithms by just using a sort function in inbuilt function which is in STL. But in the interview, if the interviewer asks you a question specifically to that algorithm, you have to answer or you have to display that algorithm like merge sort, bubble sort, or anything else. Now let's get started with the today's question. So today's question is also on LeetCode, and this is based on the binary search. So firstly, let's understand the problem statement with our like old way in which we used to do the problems. That is like taking screenshot code and then pasting it here. And now let's break down this code one by one so that we can find like which way we can find the solution for this. So binary search is the name of the problem, and it will be like we will be given an array, and this will be of integers. So what we have to do is it will be already in sorted order. So we can say it is in sorted order, and sorted also in ascending order, and there will be a target which will be given to us, target named as t. So we have to write a function to search that target if that number exists in our array or not. So if that exists, we have to return the index, otherwise we have to return -1. Pretty simple question. Pretty simple if we go just by this method only, like like searching, like how we can do this. So if I make a for loop from int I equals to 0 and going till nums dot size -1, and then just iterating through the array, the simple way, and then I will just write a condition like if our nums ith index anywhere it comes out to be target, then and in that case the we have to just return the value, and what we have to return is the index. So I, and then at the end I also need to return -1. And why I need to return -1? If in the loop that specific target element is not present, then in that case we have to return -1. Now let's run this test case and see if it works or not. Hopefully it should work. Accepted. We have to find 9 in this array, and the index is 4, which we have like returned specifically. Now let's submit this and see if it works here also or not. Wrong answer. Okay, it has given us the wrong answer. The output is given as -1, and this is the case. Like if we are able to find that problem first. Okay, I have written -1. That's why it is happening. It should not happen actually. I should write I equals to nums dot size -1, but I also write -1 and then write the less than sign. It got accepted. It got accepted. So, do you think the problem statement with which I have came up here in this video would be of that much easier level? Like, okay, just writing a for loop and finding the target element and just getting out of it. For sure not. Let's like reset the code, and this code is pretty simple. Like you just have to find the target element. But what happens in this case? In this case, what will be the time complexity? If you have bit of knowledge about what how to analyze time complexity, then you can understand the time complexity of this specific function which we have written here is big O of n. So big open time complexity. Okay, fine. Let's reset this code, and then again let's get back to the question. See the question here, it have specifically mentioned we have to solve it in logarithmic time. It is log of n. So if we have to solve this question in logarithmic of n, it means we have to decrease the time complexity. And how we can do that? What can be the method of doing it? Although it is not recommended or it is not shown that like in every case you have to go for a binary search. Reason I will tell in the upcoming one. So first of all, we have to do it in logarithmic time. So whenever you encounter, we have to do it in logarithmic time. We have to the time complexity. We have to decrease the time complexity which has been used here, and what sort of algorithm we can derive, or what sort of algorithm we can use if we want to find the solution of this problem in this specific time complexity with the use of binary search. Yes, you heard it right. Also, the question statement is of binary search, so you should have guessed in the beginning on like it can be done with the help of binary search. So what happens in binary search? I will not go in the theoretical way. You can go to Google and just search about binary search. You will get the form definition which you can write in the in your portion in the question paper or answer paper. But if you have to tell in the interview, or if you have to just get the basic knowledge how binary search works, so it is like you will keep two pointers. One will be left, one will be right. Now, for applying the binary search, the first, or I can say the primary pillar is it should be sorted, and sorting also in the ascending order. It is done here, so it should be in a sorted order so that we can compare and we can analyze, or we can assume at least. Now, what we have to do is two pointers left and right will be here. There will be a target element. Just suppose in this, the target is given as 9. This is our target element. So what we will be doing is, or what the intuition of solving this problem statement is, what if in this problem I will take a mid. I will take a mid just to, so for taking the mid it will be left plus right divided by 2. So if I will reach somehow the middle number, or like the middlemost index, so it will be like 0, 1, 2, 3, 4, 5. 5 divided by 2, it comes out to be 2.5. But although right now in this problem statement we are not going for the point 0.5, so we will be flooring this value. It will be at second index, so we will be at this index for sure. Now what we have to do is, at this index we will be seeing, okay, 3 is the number which is present at our middlemost index. Now we will start a comparison. Now we will eliminate one portion and then just think about the other portion. So how we will be performing it is, if 3 is the number, I will firstly compare it with target. If our 3 is greater than our target, if our 3 is greater than our target, whatever target we have got, if it is greater, in that case, it means the target will be in this space. If our target is less than 3, okay, and our left pointer is at the leftmost corner only, so it means our target will be here. But right now it is not happening, so we will not take this case. Otherwise, if it happens, what we have to do is we have to just take our right pointer and place it in mid minus 1. And according to that, mid will also get converted, because in the next iteration our right will be something else. In this iteration right is at 5, but in the next iteration it might be at 1. So that will happen, and if our 3 is less than the target, it means our target is in the uppermost belt, or we can say we have to take the left pointer and take it at mid plus 1. That we have to do. Take the pointer and place it here after the mid. So what we will be getting is, every time when we will iterate, we will be taking the mid element, comparing it like on which section we have to go, eliminating one side, moving further, eliminating one side, moving further. And that's how we will get that time complexity of logarithmic of n in the problem statement. Now let's code this and then try to see if it works or not, the intuition which we have derived. So if I will go here, first of all, as I have said, the first step will be to make a left pointer, which will be initially at 0, then a right pointer also, which will be at nums dot size minus 1. Now we have that both pointers which we have. Now we have to iterate in this array. So for iterating, I will be preferring using a while loop, because in while loop we can control every single thing which we have. So writing a while loop in which left will be like if we will be iterating in the while loop till our left is less than or equals to our right, just simple. Now we have to find the mid, which I was talking about. Mid, it will be for sure like to find the middlemost element between two numbers. It is just like finding the average of them. or we can write it like this. Dividing it by 2, we will be getting the middlemost index, just a simple case. Now let's write the conditions which I was talking about. Like there will be different conditions based on the situation. If if in a case, if in a case, so first of all, which case we should consider? If you found the answer, if just suppose while iterating in this, our middlemost element is the element which is equal to target, then we just have to return mid. And if the target is less than the mid, then we will do something else. And if target is greater than the mid, then we will do something else. But if it becomes equal to the mid, then we just have to return the mid, means the return the index of that target element, isn't it? Now let's write this. If we go for num, and the thing which we will be considering is the mid. If it is equals to the target, in that case we have to return the middlemost index. Now next will be our other condition, that is first of all else if in the case if our num's middlemost index, so if we get our middlemost index is greater than the target, so just suppose if we have target as given in the question, there is written the target is 9. Although we found the middlemost index, but we found it is smaller than it. But in the case when it is larger than our target, so it means our target will lie between the middlemost and the mid, less than the mid. That will be the case. So according to that, as I have written, if this is the case, if the middlemost element is like this, then we will just write the right, take the right pointer, take the mid, -1, so that we can, like in the next iteration, our right will get changed, our mid will also get changed based on our right or left, and then we will move on to the else condition. Else will be the left, if our left, like if in the case, if our num's middlemost element is greater than our target, then we place right pointer at the mid -1. If in the case it is smaller than it, in that case we have to take the left pointer and place it after mid. Just simple. Now, in out like out of this, we have to write a return, and what we have to return is -1. So I think we are done with the problem statement. Now let's run this once and see if it works or not. It got accepted. Let's submit this also. Hmm. It got accepted. Now let's go to the description. Now, like while solving this problem, you should not see like, okay, 74 or 85 milliseconds. It is going and here and there. Okay, we can, although like we just need to understand what will be the time complexity of this specific problem. And when we do this, like let me submit it again. There we will get, we are getting an error return. I don't know what is the issue. Yeah, it got accepted. Now, if I click on the analyze complexity, you will be getting the complexity of logarithmic of n. So the previous like approach which we have followed is perfectly fine. There is no worries. It is in big O of n. But what tip I want to give to you, if in a problem statement it is given the array is sorted and you have to find the or if you have to find the solution in the logarithmic time, then try to think about the binary search as a possible solution for that specific problem. So that's what how we encountered this problem and we solve it. Although the simple approach, iterating once and giving the solution, I have already told you, but this is the correct approach because in the problem statement it is written you must write an algorithm with of logarithmic of n. So you might pass the test cases or the coding round, but in the interviewer, if interviewer will ask you this problem, you have to solve it in logarithmic. So that's all for the video. I hope you liked it and I hope you will practice this also. So that's all. Thanks for watching.